Hey guys, Al here, Vitalize Seed. Hope everybody's having a good day. Wanted to talk about organic matter mineralization. So, why am I able to create this type of soil aggregation? Obviously, you see the worms in there, as well as this dark, rich topsoil on top of what was previously compacted logging deck in an area that's not known for really good agricultural soil. So that particular CEC there is like an 8. So it's a lighter textured soil, yet we're building topsoil right on top and actually breaking up the compaction layers through roots. There was quite a bit of roots down through there already breaking that apart and helping to create better soil stable aggregation through there. So how are we doing this, and why are we able to achieve this in a relatively short period of time? This picture, that part of the farm has been in the 1-2 system for around 4 years. Obviously, the last couple of years, it actually was under Vitalize Seed. Prior to that, I was using these mixes before we started the company, so I do want to be clear on that. So how are we able to do it? Well, one of the things that we're doing is using the 1-2 system, maximizing diversity. We're doing things like using our seed armor and seed feed, which are beneficial in helping to make sure that the plants are off to a really good healthy start, making sure we have the right bacteria in there, etc. We also used the Tanio products this past year, which I believe is helping, although I've only been using it for a year or two now. Time will tell, but those help with mycorrhizal fungi inoculation. But even without that product, because we're using no-till systems, we are aiding the mycorrhizal fungi connections, which is just basically root fungus, and we're aiding those connections within the soil profile, and we're building really good quality soils pretty darn quickly without any amendments. So other than lime, there have not been any amendments on this particular field that I'm showing behind me in this picture. So what is organic matter mineralization, right? So it's a good thing in some instances. I mean, it does happen naturally through microbial communications. But when we till, we speed up that process. And basically what it is, it's taking your organic matter, so leaf litter, thatch covering, etc., all the things that are in organic matter, right? And you're turning it into inorganic forms that are assimilable by plants, which is really good if you have a living root right there. However, if you're tilling, it's happening really, really rapidly. So you're getting this flush of inorganic nutrients becoming available, and not all of it can be assimilated. So then what happens is it ends up being lost, and your microbes are then propagating because there's oxygen into the system, and now they're hungry and they're looking for a carbon source. And if there's not a carbon source there, they're going to feast on that organic matter, literally mining your organic matter out of the soil profile. So that other chart showed it as well, but we've talked about it a lot. What is important is carbon nitrogen ratios. And as I mentioned previously, the previous slide was talking about the idea of naturally occurring organic matter mineralization through microbial systems. And that's what happens when you understand your carbon and nitrogen ratios of your thatch layers and root systems and things like that. And as you stimulate your microbes in the soil, the faster you'll be able to cycle some of that organic matter, and also the faster you'll be able to make stable organic matter, where you get that really nice dark color, and that being in humus. I've often heard it referred to as the fungus kind of chew on it, right? They feed and feed and feed and feed on root exudation. And then eventually, the byproduct of that is a super stable substance. Another common term used, or an offshoot of that, when fungi is getting fed, which does really, really well in no-till systems. Fungi does not like disruption, is glomalin production, which is the production of a biotic glue, which helps the soil to hold together. But you have to understand these carbon and nitrogen ratios is what we preach heavily in our 1-2 system, so that we can cycle these nutrients and you don't have too much immobilization and you don't have too much mineralization. Or another way to think of it is mobilization of nutrients to where they would leach out of your soil profile. I just thought this was interesting, because a lot of times we think of, we want organic matter, above ground biomass. As this source shows, very little of the organic matter is actually coming from, it shows a little bit, obviously, above ground biomass. It mentions leaves and needles, so that would be your above ground sorghum stalk or corn stalk or anything like that. But the other three categories are all below ground. So if we can lend ourselves to a system that is aiding the below ground root mass, macrofauna, and microfauna biology, we certainly can make a larger impact fast. Not saying we don't want to have any soil coverage in thatch, but 3 out of the 4 are below our feet. So what happens when, this is obviously from a UK research paper, but what happens when you do till, or as they spell it or mention it here, plowing? It's what's called redox reactions in chemistry, but basically, your oxygen's going in, carbon dioxide's coming out. So you're losing some of the carbon stores that are in the soil through that tillage, not to mention breaking up soil stable aggregates, breaking up arthropods' homes, chopping up earthworms, tying up other elements like iron through the oxidative reactions, etc. So it gets really long-winded and really into the weeds in the chemistry of redox reactions, and it's pretty fascinating if you're interested in it. There's a lot of research you can read on it, but in general, I like this article because it kind of just, or this picture, I should say, because it kind of just highlights what is happening when you do plow a field. And a lot of times, a lot of the tilling or plowing that's done can be done recreationally, and we really just do not need to be doing it as frequently as often is being done, especially if our goal is soil health. So to end, I mean, if you want to, check us out at vitalizeseed.com, we sure do appreciate it. I hope you guys found this informative and interesting. But if you want to be able to try to build soil stable aggregates, carbon sequestration, etc., what does it take? Well, it takes diversity. It takes diversity in root mass. It takes diversity in microbiology. It takes balancing that carbon and nitrogen ratio so you're not having immobilization or tie-up so that one feeding isn't feeding the next, right? So don't buy into just, this is a soil building mix, singular. We need to have a system that's going to work from one after the next, after the next, after the next. It's a multitude of programs that are going to really help. And that even works in an ag setting. If you're doing corn, let's say, that's okay, but what are we going to then put in after corn as a cover if we're in an area where we can do that to help that system capture the nitrogen, etc., so or the nitrates in the soil. So that's really what helps us to continue to build on our soils, make them better, increase organic matter levels, increase water infiltration, increase nutrient cycling, and reduce our need for inputs. And that's all going to be done through reducing, basically following the 6 soil health principles, but no-till, diversity, root structures, and balancing those subsequent plantings like we do at Vitalize Seed. So hopefully you guys found this interesting. Check us out, guys, at vitalizeseed.com, and we sure do appreciate you.